going to be working more with exponents here, and we're going to see that once again we have some new properties, but they're pretty intuitive. There is a shortcut that people saw. This is what's happening. So let's get in here and I'll show you. So this is what the shortcut is, but let me just talk through it here and not use math language. So if we had, this is an unfortunate one. We got so many. Okay, you could do this without having so many of them, but okay, here's what's intuitive. If I had x to the ninth, isn't that 9x's on top? And on the bottom there are 7x's. Well, these are all being multiplied, and so that makes them factors. And if they're factors, you can cancel out the match. Every time you've got an identical factor on the top and the bottom, you could cancel it down. And if I cancel down each of the matches, so there was a match, there's a match, all the way down, I would have 2x's left. And those 2x's are on the top. So my answer would be x to the second. Now, if you see what's happening here, I could make 10 threes on the top and 2 threes on the bottom. You cancel it down, and you're going to have 8. And someone saw this over and over as they thought this through, and they're saying what's happening every time is that I am simply subtracting the bottom away from the top. I got x squared. Well, it was 9 minus 7, 10 minus 2, and that's how we're simplifying these. So, wow, there's so many of these. Let me just do one more here like this. So if I had x to the fourth, there's 4x's up there, 2 on the bottom. Well, these are multiplied, so these are factors. So every match could be canceled. There would be left with 2 on the top. But I could have seen that what's always happening is I'm just subtracting away the bottom exponent from the top exponent. I get x to the second. So when we look here, we're subtracting these, and so it's x to the 15th minus the 10 from the bottom. I'd get x to the 5th. And if you see in your head, wouldn't you have 5 left on the top? You would. Okay, so our second one here, we've got 6 to the 14th power minus the 5 from the bottom. We're just subtracting those, and we must have 6 to the 9th. Okay. Y to the 43rd minus 36. Now you don't have to show this subtraction. I'm just showing you the principle, where it's coming from. So we could just subtract them. You could write them all out. They just keep using huge numbers. Okay, now if you see what's going to happen here, we're going to have more on the bottom. Let me see if they're jumping to negatives. Okay, they're going to leave them on the bottom. Okay, so let's go and do what we did before. I want to show it to you like this. So we said that we subtract, right? So wouldn't this be b to the negative 4th? And so what must be true if you subtract this? So let me show you with some smaller numbers so I can make them easier. Okay, cancel, cancel, cancel. So what I have left is 1 over 2x's on the bottom. You can't just make them move to the top. And so look what I'm having occur here. We say x to the third minus 5 is x to the negative second, right? If that principle holds true, doesn't it have to be true here? Well, here's what I'm getting at. X to the negative second must be the same thing as 1 over x to the second. And so if you have a negative exponent, what you can do is you can move it across the fraction line down to the bottom. And actually, sometimes later we'll see vice versa. But so here's what I'm getting at. These two must be the same thing because they're intuitively doing the same thing. So x to the negative 2 has to be the same as if you can get rid of the negative by just moving it down to the bottom. It must be the same as 1 over x squared. So here, when I subtract these, I get b to the negative 4th. Well, that has to be the same as if there were 4 b's left on the bottom, which if you think about it, that's true. So these two things have to be the same. So I have 7 to the third minus 5. That's 7 to the negative second, was what our shortcut says. Well, what can that mean? It has to mean 1 over 7 to the second. And since that's a real number, we could do that. It's 1 over 49. Okay, so I've got x to the 18th minus 22. You may even see where this is going, but This is x to the negative fourth, right, if we do the shortcut. Well, if we had canceled them down by hand, it must be the same thing as 1 over x to the fourth. So I can get rid of the negative exponent by moving it to the denominator of the fraction. Oops, what am I doing? We have 12 to the 15th minus 30. Okay, well, what is that? It's 12 to the negative 15th, but we don't want that negative exponent. Let's just move it back to the bottom, which is where it must have been if I had just canceled them all out. Now, sometimes you can find that number. If it's a real simple exponent, a real base with a simple exponent, we can find it, but it's something like 12 to the 15th. Just leave it like that. Okay, we've got m to the 7th minus the 15. So the shortcut says that must be m to the negative 8th. If you had done it the long way, you would have gotten that. So these must be the same thing. Okay, here's another one. Whoops. So 9 to the negative 11th. So that we can just move it to the bottom, and it becomes a positive exponent. Okay, these are the same. I don't see anything different about this. Hold on, are they gonna? No, they're doing the same thing. Okay, so we've got 1 over a to the fourth. Okay, x to the fourth. Okay, so they're just mixing. Some are, some aren't. So this one we had 4 left on the bottom. Here on the top we have them. They're all left on the top. Does that make sense? Okay, so I've got b to the 19th. Just going to do the shortcut. That's b to the 8th. And now that's on the top. That's a positive number, so we're done. Now this one, however, c to the 5th minus the 11, I get z to the negative 6. Now that's a negative. We don't want to leave it like that. Let's move it back to the bottom where it belongs. And if you see here, when you've had 6 left on the bottom, if you canceled it down. Okay, so I'm doing the shortcut here, and I'd have p to the negative 8th. Let's move it back to the bottom. Here, I'm doing the shortcut, and I get w to the 4th. Okay, now they're being kind of cute here in the next thing. Hold on, I'm trying to think of a way that you've seen this before. Oh yeah, here's how to show it to you. Sorry. Okay, so suppose I had x to the third over x to the third. If I canceled all the x's down, I knew there was a shortcut to this, so we cancel all those down. Now it looks like everything's gone, but you remember when we cancel factors, it really leaves behind a 1. So this is actually 1 over 1, which is just 1. Okay, well now the rules of math can't break. So if this is 1, look what happens here. I also said that we could subtract the exponents. Well, if we do that, what we get is x to the 0 power. Well, hold on. What we're saying here is these have to be the same thing. So one more time, let me take you through. X to the third over x to the third has 3x's, 3x's. It would all cancel down to 1. Well, if I did our shortcut, we'd have x to the 0th power. So x to the 0th power has to be the same as 1, or the rules of math have been broken. And so x to the 0 is defined to be 1. And if that's true, anything to the 0th power is going to be the number 1. And so all of this is being taken to the 0th power. Okay, well it's 1. All of this is being taken to the 0th power. It's also 1. Okay, all of this, so do you see where this is going? All this to 0, that's 1. All of this to 0, that's 1. 1, 1. Okay, now I think this is our last new property here. And let me show it to you like this. So suppose I had 2/3 to the 2nd power. Isn't that 2/3 times another 2/3? That's what it is. So we get 4 over 9. Now, let's suppose I had broken it down differently. Suppose I had given that exponent to both the top and the bottom. Well, I'm going to get the same thing, 4 over 9. Now, this is not a proof when you just show one example, but it is turn out to be true that you can essentially give that exponent to both the top and the bottom, the numerator and the denominator. And when you do, you'll get the same result. So if we look at b here, I'm going to give that exponent to the top, and I'm going to give it to the bottom. Now 3 to the 4th we should do, that would be, what would that be, 81? So we could tidy that up a little bit more. Okay, so I've got one more c here. We'd make that k to the 3rd over j to the 3rd. Okay, we've got some more here. Let's make this 5 squared over 8 squared, or 25 over 64. Let's make this p to the 4th over 10 to the 4th. And let's make this m to the 7th over n to the 7th. Okay, I've got 1 to the 3rd over 3 to the 3rd. Well, that's still just 1, and that makes 27. Negative 2 to the 3rd. Now, I wanted to make sure you saw it's all the negative 2 is being taken to the 3rd. The negative is being included. So that would be negative 8 over q to the 3rd. I'm given the 4th power to the top and the bottom, and I would get that. Okay, so some new exponent rules. Again, I think they're all pretty intuitive, except maybe x to the 0, but I hope what I showed you made some sense. So hopefully those rules will stick with you.